Testing 1, 2, 3 again. Okay, this time what we're going to do is we're going to take a number like 5 in base 10. The base goes to the bottom. I want to convert it to something in binary. Now, the way you approach this problem is what I call the brute force method. You just force the numbers in there. So we're going to start with our table 1, 2, 4. And I draw the table, I write the table. Remember, this is 2 to the 0. This is 2 to the 1, 2 to the 2, 2 to the third power. If I had another one, 2 to the third, 2 to the fourth, 2 to the fifth, etc. I mean, I can go as big as I need to. So here's what I do. I say, okay, I got my little chart there, and I'm going to draw it until I at least get a number one larger than the number I'm looking at, 5. So 8 is one larger, so I know that I can scratch that out, and my number is to the right this way. Okay? In other words, my answer is within the bits 4, 2, 1 columns. Okay? These are going to be zeros or ones in here. You can already kind of see the number fall out probably. But I draw 1, 2, 4, 8. I draw it one bigger. I put the 8 there because it's one bigger than the 5 because I know everything else is to the right. And I've kind of met the left boundary, so to speak. If I had put it minimum, at least a 1 there, what would happen is this number would be at least of a value 8. And that's not going to work because I'm asking for 5. So here's what I do. I take the 5, actually the 4, and I compare it to the 5. And if the 4 is less than or equal to the 5, I keep it. But then I got to subtract it. So I say 4 is smaller, less than or equal to 5, so I keep it. And then I'll move to the right. So now I have 1 left over, so because 5 minus 4 is 1. And so I compare 5 minus 4 is 1. I compare that 1 to the 2. Well, the 2 really to the 1. Now the 2 is bigger than the 1. So I don't need it. So I put a 0 there, mark it, and move on to the last one. And then the last one is 1 compared to 1. Is it less than or equal to? Yes. I need it, but I have to account for it. So subtract out, and I get to 0, and put two little dashes there like in accounting, saying I'm done. And that is your answer. And that's the process. That's the algorithm. Let's do another one. Let's take the number 45. I did this one in my little binary to decimal conversion. And 45 base 10 is what in base 2? Well, draw my chart. And remember, I draw it one bigger than the number I need. 1, 2, 4, 8, 16, 32, 64. Sorry for my writing, but I'm doing it. I'll put some columns in here maybe. I don't know if that's confusing you or not trying to. All right, now, I know that 64 is too big, so I count that one out. But I know that my values are somewhere in here, right? My answer is somewhere in there. So I start off with 45, and I compare that to 32. Well, really, I look in the table first and say 32 compared to 45. Yep, I need it. What's the difference? Is that right? 13? Right. Well, 16 is too big. 8 is just right. 5 left over. All right. So once I mark it, you see I have to account for it. There's my 32. There it is. There's my 8. There it is. And then 5 minus 4 is 1. And we did this one a minute ago with the 5, doing the 5, right? And minus 4 is 1. Compare 2 to 1, too big. 1 is just right. Run out of room. And then I'm done. 0. When I get to 0, I'm done. And you can kind of look at it. And this matches the number we did a while ago in the other binary to decimal discussion. Okay. Thanks very much. Copyright Todd Metters, 2007.